Hello, and welcome back. This is the second section of our series, 3D Game Development in Unity 5.x. This section is called Let's Add the Game. Now that our core components, the player, the camera, and the enemy AI are built, we need to actually implement the game's gameplay loop. That's the goal of this section of the course. To make what we've built and bring it closer to a finished, shippable shooter, we're going to have to finish the core gameplay loop. First, we need to build weapons for combat in 3D, extending the existing weapon system of our game framework to handle projectile weapon combat. Next, we'll want to build a system for keeping track of the player's progress, which we'll accomplish using a save game system. Finally, we'll build enemy spawners to dynamically add enemies to the level in ever more difficult waves so that our players have an endless challenge ahead of them. Let's get started, shall we? Our first goal is to extend the game framework's weapon system to work in 3D. We'll begin by opening the Packed Game project in your Section 2 supplemental materials in the Start folder. This is essentially the project as we left it at the end of the last course section, but I've added some more of Unity's standard assets, primarily the Particles asset package, so that we can use them when we build weapons. Okay, now that the project is open, we'll do a small amount of prep work by going to the Content Prefabs folder, and here we'll create a new folder called Projectiles. Then we'll add a second new folder called Weapons. Later, when we build our weapons and the bullets they fire, we'll be glad these folders exist. Moving on, we want to go to Scripts, Interactables, Weapons. Here we want to create a new C# file called Projectile Weapon 3D. Once the file is created, we'll open it in our IDE. The first thing we want to do is change the reference to mono behavior in our class declaration to BaseWeapon, so that this class inherits from the game framework's BaseWeapon class. As usual, I'm going to paste in the C# code here so you don't have to wait for me to type it all. I'll go over it line by line, so feel free to pause at any time to enter it for yourself. This file will be about 128 lines when we're done. The very first thing you'll notice is that we're using this header attribute to group our public variables together into categories. This is a handy feature of the Unity editor that puts a little space between each collection of variables in the inspector panel so that it's easier to read and keep organized. Our first group is the firing properties, the variables that define how the weapon actually launches the projectiles it fires. First is the projectile prefab variable, which will point to a prefab of the actual bullet we're going to use for this weapon. Then we define the weapon's muzzle velocity, or the speed the projectile is moving when it leaves the weapon. The firing time variable describes how long it takes the weapon to fire. If the player tries to fire the weapon again before this time is passed, it will not fire. The firing point offset variable is where the weapon will place the projectile in front of it when it spawns. Typically, this just ensures that the projectile is far enough away that it doesn't accidentally register a hit with the weapon that fired it when it spawned. Our next group of variables are the accuracy properties. If the bool simulate inaccuracy is true, then when the weapon is fired, its path will deviate slightly from perfectly straight, simulating each weapon's inherent inaccuracy. The inaccuracy max and inaccuracy min variables tell the player how far it can deviate from straight, both in the x-axis, left and right, and the y-axis, up and down. Now beneath these two categories are our protected variables. The current ammo float variable tracks how many projectiles are currently loaded into the weapon. The firing variable is a simple boolean we use to know if the weapon is presently firing or not. It's used in conjunction with the time firing float to control how quickly the weapon can be refired after it has been fired once. And finally, the PLR variable is a reference to our player, which the weapon uses to determine its owner. The first method in our new class is the protected override void method onStart. We run the BaseWeapon's onStart method to initialize the core weapon functions. Then we initialize our _PLR variable and set our _current ammo variable equal to max ammo so that all of our weapons will start fully loaded. Next, we define the private void method fixedUpdate. This is a standard Unity event, which you might recognize as the update loop where physics-related behavior is defined. In our case, we call the method onFixedUpdate, which we define directly below. OnFixedUpdate simply manages the gun's firing tracker, adding the time that has passed since last frame, time.tilde to our time firing variable if the weapon is presently in the firing state, and setting the _firing variable to false so that we exit the firing state when the necessary time has already passed. Now we create the protected override void method called onAttack to handle our core attacking behavior. In this method, we check to make sure we're not already firing and we have at least one projectile to fire. If these conditions are true, we set _firing to true. Then we deduct a projectile from our current ammo count and reset the time firing counter before calling the fire projectile method. And in the fire projectile method, we pass along the projectile prefab that we want to use to fire and the muzzle velocity, the speed at which we want to fire it. Finally, if we cannot fire the weapon, we set aside a code block for messaging that back to the player with a comment to remind ourselves to play the dry fire sound when we can't fire the weapon. We'll implement audio in a later video. Now, we define a protected virtual void method called fire projectile that takes in a game object variable called projectile and a float variable called speed. First, we define the firing position of the projectile by taking the weapon's location and adding it to our firing point offset in the forward direction. Next, assuming we have a projectile to fire, we instantiate an instance of the projectile and store it in the variable _proj_obj. Then we get that object's base projectile 3D component and store that in the _proj variable. If the proj variable isn't null, we then call its SetUpP projectile method, passing in the weapon's range, the damage it deals, and our owner, the player. Once that's been done, we zero out our weapon's local rotation so that it's facing directly forward. And if simulated accuracy is true, we can then determine how much to deviate the weapon's aim by the shot, storing the results in the X deviation and Y deviation variables. Once we know our deviation, we rotate the weapon to match, set up our projectile's position to match our firing position, and set its rotation to match the deviated rotation of the weapon. We're now ready to fire. To do that, we get the rigid body component of the projectile. Then, if it's not null, we determine its movement vector by taking our weapon's forward vector and multiplying that by the speed variable. Then we set the rigid body's velocity value to our new movement vector. And with that, our projectile is fired. I've also added two methods at the end of the class here to handle ammunition management. Right now we can't actually reload a weapon, but that will change when we add ammo pickups later. The first of these ammo methods is a public vector2 method called getAmmoState. This simply returns a new vector2 variable with its X value set to the weapon's current ammo and its Y value set to the weapon's max ammo. The last method of the class is a public bool method called reload that takes in an int called AMT. In this method, we check to see if current ammo is less than max ammo. If not, we immediately return false because there's nothing to reload. Otherwise, we add AMT to current ammo and then reduce the value of current ammo down to max ammo if it's greater than max ammo. That way we never have too many bullets in the gun. And then finally, we return true to let whoever called reload know that we successfully reloaded. So that's it for the Projectile Weapon 3D class. That's our base weapon class. However, as you saw, there are a couple of places here with these red squiggly lines, specifically where they reference base projectile 3D. So our next step will be to create that class. Let's go back to Unity. And in our Scripts Framework Interactables Weapons folder, we want to create a new C# script called Base Projectile 3D. And then we're going to open that up in our IDE. The very first thing you'll notice is we're using a require component attribute, which calls for a type of sphere collider and a type of rigid body. This attribute forces these components to get added to the object that you add this component to, which ensures that the projectile has all of the pieces necessary to function. Now here you'll see we have another header attribute just so that we can group our projectile properties together in one place. In this case, there's really only one public projectile variable, this impact prefab variable, and this actually points to the prefab that will be activated when the projectile strikes something. So the sparks that are thrown up when a bullet hits metal, or the explosion of a rocket when it hits its target. Beneath this, we have several protected variables. The first is our firing point, which is really just a location record for where we originally fired from, which is useful to determine how far we've traveled, followed by the actual range we're allowed to travel, and the amount of damage that the projectile does when it hits its target. And then finally, a reference to the owner of the projectile so that the system knows who dealt the damage this projectile caused. So here we have a void start method. Just like fixed update or update, start is a standard Unity event. It's called as soon as an object is created, but before its first update loop. And so this is usually where we do all of our initialization things. In this case, we're calling the onStart method, which is a protected virtual void method called onStart. And all we do here is we set our firing point to our initial location, transform.position. Beneath this, we have another Unity event, a protected void method called onCollisionEnter that takes in a collision called collision. Now here we call doCollisionEnter and we pass that collision variable along. And we'll define doCollisionEnter right here. DoCollisionEnter is a protected virtual void method called doCollisionEnter that also takes in a collision. And here we determine the target by trying to get the base character out of the thing that we collided with. Assuming that isn't null, assuming we've actually hit a valid target, then the first thing we do is tell that target to take an amount of damage from our owner equal to the damage variable's value. Next, we check to see if our impact prefab is not null, and if that's true, we instantiate a copy of our impact prefab, set its position to the location of our collision, and then start a coroutine called destroy impact go, which we pass our impact go into. Finally, when all of this is done, we actually destroy the projectile itself, because once it struck its target, it doesn't need to be in the game anymore. So all we do is we define a protected virtual enumerator called destroy impact go that takes in a game object called go. Next, we'll wait for a predetermined amount of time, in our case 0.7 seconds, not quite a full second because the impact prefab doesn't need to be displayed for very long. And then we check, and if go isn't null, we destroy it. Okay, now underneath this we have one more Unity event called void update, and much like fixed update runs every frame. It runs before fixed update, and it does not necessarily run at a fixed time. It's not frame rate independent, which is why you can't use it for physics. In this particular case, though, what we're just going to do is we're going to run a method that we call onUpdate, and we define that right here. It's a protected virtual void method called onUpdate, and in it we check to see if the distance between our firing point and our current position is greater than our range, and if it is, we destroy the bullet. That means it traveled to the edge of its range, didn't hit any targets, and now it's time to get it out of the game again. All right, last but not least, we define a public virtual void method called SetUpProjectile that takes in a float variable called range, another float variable called damage, and an iCharacter variable called owner. And with these variables are passed in, we simply assign them to our own internal protected variables so that we cache their references. This should be the first thing that we call whenever we're going to fire a projectile so that it has all the data necessary to function within our framework. But once we do, that's our base projectile 3D class. And so if I save that and we go back to our project and let it compile, we should see that this error, which just did, goes away. But now when we open our projectile weapon again, you'll see that the references to base projectile 3D are now fully functional, and everything is working as intended. Which means in theory, if we were to build a projectile game object and a base projectile weapon object and put them on our player, they would simply just function.